seasons. And for a mechanism wheel drive, you have to use 4 wheels. These wheels are easy to build, and for each wheel to work at their best, there's one motor attached to each wheel right here. And however, controlling and programming the mechanism wheels can be challenging at first, but once you get the hang of it, it gets easy. Okay, that's it. Thank you.
All right, so what we're going to do now is take any questions if you have on the drivetrain or the wheels. Otherwise, we're also going to show you the wheels in real hands-on. Okay, so Ananya is going to share some of those wheels. Sit down here, or
just like I can just show like this.
okay, all right.
All right, so these are the mechanism wheels that Sia was talking about. So as you can see, they have rollers. So this allows it to move forward, backwards, and also side to side. And then these are omni wheels. So omni wheels can move forward and also side to side, but they can't move diagonally like mechanism wheels. So you can see these rollers here are what allows it to move side to side. And then these are 3D printed wheels that we 3D printed. And 3D printed wheels really just help you when you want a wheel that's a specific size on your robot. And then there are also just smaller wheels that you might need in your subsystem. So this is a really small wheel that we use sometimes to just help intake minerals or intake rings.
All right. Any questions, students?
Well, I have a question, Ananya.
Yeah.
Sure.
About this 3D printed wheels, right?
Yeah.
So have you used a 3D printed wheel in your robot?
Yeah, so one example is for our intake. So for example, in a previous season when we were trying to intake stones, the normal bigger wheels like this didn't really give us that much accuracy. Like sometimes the stones just needed an extra kick just to help the stones come in faster. So we 3D printed smaller wheels that actually go underneath the robot. So that way we were able to intake the rings more smoothly and a little bit more faster.
Sure, yeah, thank you. And the reason I asked the question is you did this printing, in your workshop, right? That where you are working on. You did your own 3D printed wheel, correct?
Yeah, we 3D printed it using SolidWorks.
Sure, yeah. For the interest of the students, so the team Robolards actually has a 3D printer, and they can print some parts that they think if they can't find it, some of the parts that can be. I want to see if you could briefly, maybe in 30 seconds, talk about that 3D printing so that they can connect the dot there, 3D printing, and how do you do that?
Yeah, so I can speak about 3D printing.
Sure. Yeah, go ahead.
Yeah, I can speak about 3D printing. So really the first step is figuring out what sort of part you need and then designing to meet that specification. So the way we design it is in this CAD software called SolidWorks or Fusion 360, where we really take this wheel and we really design every single part of it down to even the holes in the middle inside this software. So this is something you learn and then you'll get more experience with over time. And then once that's done, you do some export steps, which are pretty easy. And then you send it to this 3D printer. And the way the printer works is it uses plastic, melted plastic, to sort of form this shape. And then when it's all done, you can take it out of the printer and then you get what you see here. So you first get your specifications, design to meet those specifications, and then print. Yeah. So this is another example of a 3D printed part right here. So you can see where the advantage really comes in with 3D printed parts, where you would never be able to find this exact part off the shelf. Like no matter which store you go to, you wouldn't be able to buy this, because this is something we custom designed to meet our specific wheels and channels and motors and all of that with our design measurements and all that. So once we custom design this, we go ahead and put it on the printer, and then we can get this made out of plastic. So really the benefit of 3D printing as opposed to other parts is you can make pretty much anything you want. You aren't restricted to what some manufacturer makes or what some store sells. It's really whatever you can design and print, you can make, and you can have that.
Thank you, Akash. So there are a lot of stuff that if you cannot find out there, you can print, in your workshop where you're, building robot. Thank you so much. I wanted to ask Umair, if you can unmute in your college, because Umair is also studying engineering. Do you have a 3D printer in the college, Umair?
Umair, you can unmute yourself, or you can, put your video on also. Umair, is he here, or he just dropped?
Yeah, Umair is. I see him here. But anyone else who is actually at least enrolled in some engineering college, do you have a 3D printer in the college?
Assalamu alaikum, sir.
Walaikum salam.
Walaikum salam, Sharif. Go ahead.
There is not here. Our college don't have a 3D printer, but I have a friend who has a 3D printer.
Wonderful.
Okay,
Wonderful.
but in the institution, it doesn't have. You don't have that, right?
I don't know. Maybe look from past 2 years or college nahi gaya.
Which college you are from?
SSM.
SSM. Rihanna, do you have this in your 3D printer? Do you have it at your institution? Or Irtika? Or any other engineering students? Okay, you don't.
Maybe in mechanical department they have 3D printer.
They have? Okay. Right.
Okay, thank you. I just wanted to kind of, give a little sense to the Robotics team that even, some of the students are in the engineering college, it's even harder to have the resources. They, you don't have you don't just have the resources there. So thank you so much. Just wanted to make a point here. Thank you. I didn't mean to just, digress here. Back to you, Ananya and Kamal.
I think you're going to continue.
Yeah.
With,
All right.
right? Yeah.
So I'll go ahead and share my screen here for the next segment. Okay. Is everyone able to see the screen?
Yes.
All right. So we'll go ahead and get started with FTC Electronics. So the central component of the FTC Electronics system is this thing called the REV Expansion Hub. So this is pretty much this electronic component where you have your app and your phone and your software. And this component, the REV Expansion Hub, is what connects all of that to all of your hardware. So this would be your motors, servos, sensors, all of that is through the REV Expansion Hub. There was an older system called the Modern Robotics system. The REV Expansion Hub is the newer one. Modern Robotics is no longer supported by FIRST, but the REV Expansion Hub is sleeker, more compact, and it's a pretty easy to use system once you get the hang of it. So next up is this is what a REV Expansion Hub looks like. So you can see here there are many ports, many channels. So on the left side here where it says 4 DC channels, those are going to be connected to your motors. And at the bottom, your 6 servo channels are going to be connected to your servos. Then on the right side, on that right column, you have, I2C, digital IO channels, analog channels. Pretty much all of these are going to be used for sensors. So for example, if you have like a distance sensor that tells you how far away something is, that sensor would plug into this REV Expansion Hub on the right side here. And that's how you would use that sensor data in your program. Similarly, if you wanted to control a servo, you would plug that into your REV Expansion Hub, and then that's how you would control the servo. So through your phone, through the REV Expansion Hub here, and then control the servo. Same thing with the motor. So the REV Expansion Hub is pretty versatile. And to sort of give you an idea of what the state of the hub is, it has certain color codes. So for example, the blinking light on the REV Expansion Hub, communicates information about its status. So if it's solid blue, it means that the REV Expansion Hub is booting up. You just plugged it in and it's getting ready to start. It's also solid blue when it's waiting for communication from your driver's station. So that'll also be solid blue. Solid green is anytime it has power and active communication, blinking blue, blinking orange. You get the idea here that the light, the blinking LED on that REV Expansion Hub tells you what state it's in. This can be really helpful to figure out if the REV Expansion Hub is working and connected and ready to go, or whether you might need to do some more setup steps to make sure that you're ready to start and play your game. So that's the REV Expansion Hub. As mentioned before, there are a lot of REV Hub connections. So you have to first connect your REV Hub to your motors, servos, and sensors. So you can see this is the REV Hub here. Then you have some motors here. It's underneath this pane of glass. And using all these wires that you see, you're connecting it to the REV Expansion Hub. So that's really step one, connect your hardware to your hub. The next step is powering your hub. So once all your hardware is connected, you want to make sure that your hub is active, ready to go online. So that's where you use this RS485 serial cable, which is just a type of cable. And that's how you can connect one hub to another hub. Or if you want to give it power, you use the XT30 power cable, which again is just another type of cable, another type of connector. And this is where you connect your REV hub to your battery. So use two cables, one to connect your REV hub to your battery, and the second one to connect a first REV hub to a second REV hub. Now, some of you might be asking, why do you need two REV hubs? Well, a single REV hub has a limited number of spaces. So for example, it can hold 4 motors and 6 servos. But let's say you're building a robot that's maybe a little bit more complex and has 6 motors and 12 servos. In this case, you would take your second REV hub and connect it to your first so you can access those hardware components. I don't want to get too much into the details here, but that's just sort of an overview of what you can do with multiple REV hubs. So anyway, you've connected your hardware to your REV hub, and now you've powered up your REV hub. What do you do next? Next, you take up the robot controller phone. It's an Android phone, just like this one. And you take it and you plug it into your REV hub and you start your configuration. There are some configuration steps here where you set up your robot controller hardware configuration and pair with your driver station. So once you get that all set up, now you have an Android phone that's talking to the REV hub, and your REV hub is talking to all of your electronics. This is how you control the robot. So by doing some command on your Android phone, on your robot controller phone, you can control everything on the robot, motors, servos, you can access sensor information. All of this is through your Android phone. Now, once you get this Android phone, you have really unlimited control, and it's up to you to decide what to do. So this is where programming comes really in handy. You program your Android phone to connect, again, to your REV hub and to your hardware. All right, so how does the robot work? So this is getting a little bit into the software technicalities, but you want to update to the latest FTC driver station and robot controller app. So these are just 2 apps that are on Android phones. You just download them off the App Store or Play Store. You want to update Android Studio to your latest version. Use the robot controller app on your Android phone, upload that onto your Android phone. Pair the robot controller and driver station using Wi-Fi Direct, and configure the robot. So DC motors, sensors, servos using your robot controller app, and then control your robot using gamepad controllers. So steps 1 through 5 here is what I've just explained, where you do all your hardware setup and your software setup. Step 6 is the part that everyone is most excited about, actually controlling the robot. So you take your gamepad controller, which is just like a PS3 or a PS4 or PS5 controller or an Xbox controller, and you drive with it. So if you move your joystick up, the robot moves forward. If you move your joystick back, the robot moves backward. Once you add more complex parts, you can do more complex things. So for example, if you press the button A, maybe your robot automatically picks up some part. Maybe it picks up a wheel from the ground and shoots that wheel out the other side. So this is some of the really cool stuff that you can do with FTC. And this is really done with good integration between your hardware and your software, where in your hardware, you need a solid robot that can move and pick things up. And then your software, you need software that takes advantage of your hardware to, again, pick up the part, your wheel, and launch it. So this is really the coolest part about FTC for me, and I think for most people as well. So that's the part really that I'm most excited about. Next up, we have some diagrams of some of the electronic sides. So you have 2 phones actually in this entire setup. So this is something to keep in mind. You have 2 phones in this in your setup for your electronics. One of them is called the driver station, and one of them is called the robot controller. Pretty much you take the driver station and you keep that phone with you at all times. You take the robot controller and you give that phone to the robot. This way, these 2 phones can communicate wirelessly, and anything you do on your phone, the driver station, will be communicated to the robot or the robot controller. This is how you can have a robot out in the field, like 10, 12 feet away, and still control it with your gamepad here, with your joysticks, because these 2 phones are using Wi-Fi Direct to communicate with each other. So that's really how you get that wireless communication and that game time playing field. On this left side here, you can see some examples of parts that you can use with your REV Hub, with your REV Expansion Hub. So you have, a DC motor, an HD hex motor here from REV. You have another type of motor. You have, servos. You can get even sensors. So these are some of the sensors that we talked about. You have a color sensor. Is this red or is this blue? You have a distance sensor. How far away is something from your sensor? Touch sensor is pretty much a button. So it tells you if it's pushed or if it's not pushed. Magnetic limit switch deals with magnetism. So I guess it'll turn on when you have like a strong magnetic field. And then potentiometer is another type of sensor that tells you how much it's turned. So maybe you have a wheel on the ground and you want to turn it back and forth. Your potentiometer will tell you how much that wheel has turned in that situation. So these are some examples of some of the really cool hardware. For the most part, we work with DC motors like this one here that just rotate, and servos that again rotate, but on a smaller scale. That's what we primarily use. You can also see the battery here, which is used to power up your entire robot. So this is just a battery from REV, and that'll power up your entire robot. All right, wire management. So this is getting a little bit more into once you've actually built your robot, or while you're building your robot, how do you make sure that you do good cable management and good wire management? You want to really start with this at the earliest stages of your robot design. So you don't want to build your robot and have wires sticking out everywhere, because that's a safety risk for everyone. If the wire gets cut, it's a live wire. It has electricity running through, so you could get shocked. And if it connects back to something else on the robot, you could short circuit your robot and all of your electronics. So you really want to have good wire management. And that's why you want to think about it as early as possible in the design stages of your robot. So you could use like wires, you could bundle your wires or wrap them in a spiral sheath, like you see in the picture, that yellow thing. Or you could split a wire loop tubing. So that's just, again, tubing that you can put around your wire to protect it. So that's wire management. Next slide, you also have wire strain relief. So these are just some more wire management techniques using zip ties and whatnot to sort of keep your wires all in place. And then next up is USB strain relief. So this is, again, another type of wire management. I hope you can see how important wire management is here. So when you're connecting your phone to your REV Hub, just make sure that wire is really secure, that cable is really secured, because you don't want any disconnect issues there. Yeah, so with that, that'll be the end of the electronics slide, or the electronics section. So I hope that was helpful for anyone. At this point, we can take any questions you have about electronics, and we can actually show you a live demo as well. So I'll stop my screen share here so everyone can see. All right, yeah.
So Akash, can we, any questions? So you want to take some questions now, or?
Yeah, for sure. Yep, we can take some questions.
Okay.
I have a question. Is this REV a micro computer?
Yeah, it is. So it's in this casing like you see here. It's about this size, but it is a microcontroller. It's sort of a hub for all of your electronics.
Like Arduino?
Yep, exactly. Yep, like Arduino, like Raspberry Pi, similar to that. All right. Are there any other
Let's ask Irtika. Do you have any question, Irtika, about what Akash just shared?
Not yet.
All right. So I can show a demo now of the REV Expansion Hub. So this is what it looks like. And get it up out of here. This is what it looks like right here. And there are two here. So there's one at the top and one at the bottom. And you can see I'm using that RS485 cable to connect the two together. Now, when I turn this on, you're going to see some of the blinking lights that we mentioned before. So once you turn it on here, you can see this orange blinking light. Does anybody remember what that means from the slide?
Yeah,
it's not. Yeah, it means it's. Yeah, it means it's getting set up and it's booting up, or in the process of getting all of its connections together. So it's in progress of some task. At this point, it's looking for the phone actually. So it's going to stay like this until we turn the phone on. But you can imagine how maybe these lights would turn green or blue or some other color to indicate some other function. You can also see some of the ports here that I mentioned. So on this left is all of your DC motor ports. So if you had a motor, you could plug that in right here. on the top here, you have all of your servo ports. So you have a servo, you plug that in here. That's how you control that. And on the right, you have some of your sensor ports, and this is how you would get your input from your sensors. So that's like a real REV Hub that you can see in action. And this is exactly what we use on our robot as well. Once you plug everything in, you configure everything in your Android app, in your robot controller app, and you're ready to get set with starting programming and playing. So yeah, does anyone have any questions, any other questions about anything that we talked about? So that can be electronics or even hardware, chassis, anything else.
No, it seems, very interesting, because, we don't know any basics of it. So just seeing, all those things, it's kind of a, kind of a, more in detail. So
Yeah.
it takes some time.
Yeah, and it's cool to see that people are making those connections with like Arduino and microcontroller and all that, because really at the basic level, it's like really, really similar to that. So if anybody has worked with Arduino before, where you connect in a motor and then use your Arduino programming language, this is FTC is based on that. You have your hardware, and which is your REV Expansion Hub, which is similar to your Arduino microcontroller, plugging it in also to your DC motors and servos, just like you would do in Arduino, and then program it again, just like you would do in those Arduino levels. So this is really just taking that and then taking it to the next level. So yeah.
So Sharif, have you worked with any Arduino, any programming in Arduino, Sharif?
Yes, sir. I'm working on Arduino.
Okay, good. You want to briefly tell us, like in 30 seconds, what you do with it?
So actually, I bought it just a few days back. Actually, I was kind of interested in Arduino, so from YouTube I learned some basics like servo motor and little bit of basics.
Wonderful, wonderful.
Anyone else besides Sharif?
I did some basic projects also from it.
Good. It's good to know, have some background, because it helps us to kind of, understand a little bit more. So, Umair, can you hear us? Do you have any experience with Arduino or Raspberry Pi, any of them? Umair, I don't know, Umair, if you can still hear us.
Okay, Umair has basically written in the chat box.
I have I have a question to Akash, sir.
Okay, please. Umair, please.
Yeah, mute.
Okay,
Umair.
Akash, I just wanted to tell you that I have already installed Fusion 360 a month ago, but I am still unable to, how to learn it very quickly or how to gain control on this. That's what I was talking about, that how can we learn it very easily? Any leads on how to,
Yeah, that's great. It's great to hear that you've already installed it. That's really the first step, is getting started. And it's really great to hear that. So once you've gotten it installed, the next step is, I would say, practice. So the best way to learn with these sorts of engineering things, rather than reading a book and then going through it, is to actually try yourself. So there are some Fusion 360 tutorials that you can just get from the Autodesk website. There are also some YouTube links, some YouTube like tutorials for how to build. So if you send us an email at robolords@gmail.com, I can send you more information and specific links on that. But just generally, you can look on YouTube. There's some pretty helpful links there. And the Autodesk community. So if you look up Autodesk Fusion 360, it can also help with that.
Sure. Thank you.
Yeah, sure. And for those of you that don't know what Fusion 360 is, it's that CAD platform. So earlier, if you saw, we were talking about this wheel, how we 3D printed it. We did that using Fusion 360. So that's what we used to actually design this and get it all ready to go, and then just print and then send it to print. So it's really great that you've already installed that and are ready to go.
Thank you, Akash.
Yeah, sure.
Fatima, I wanted to ask, did you have any questions? Fatima is our 10th grader and very interested, Akash, in STEM. So Fatima, any questions that come to your mind?
No, not at all right now, but I guess I will get a few soon, because I just joined the session. I was in another class, so yeah.
Okay, good. Thank you.
And I've also just put in the RoboLord's email, which is robolords@gmail.com. So if anyone has any questions, so like for the Fusion 360 information, feel free to send an email, send you more links. If anyone has any other questions that you remember like after the session, if you send it to that email, we'll follow up and help you out there as well. Yeah.
Great.
All right.
Anyone else has any question? किसी और को कोई क्वेश्चन शेयर तो नहीं करना इसमें? Ifat, what about you?
Oh, sir.
Okay.
All right.
ठीक.
So if that's all the questions.
I have,
Yeah. Oh, sure. Go ahead. Go ahead.
Akash, I have one more question. Sorry to bother.
No, not at all.
Please,
That's
please.
great.
I just want to know, can we make, you told us about Fusion 360, how to design a 3D model unit. Can we design, I actually know much about AutoCAD and, AutoCAD version 2016 and 2017. Can we make a 3D model using AutoCAD rather than Fusion 360?
Yeah. So AutoCAD is, that what you're already familiar with. That's great. There's also Fusion 360, which is, what you know about. There's another one called SolidWorks as well, which is just another option. All these CAD platforms, at the core, it's basically the same thing, right? So you design something the way you want to design it. And if your question is directed towards 3D printing, yeah, you can also use AutoCAD, Fusion 360, SolidWorks, all of this for 3D printing. So if you're already familiar with one, that's great. You can use that.
Okay.
So yeah, that'll be great. The reason we use Fusion 360 on our team is because it has some cloud capabilities. So if I design something on, my laptop and I want to share it with someone else, I can do that pretty easily through Fusion 360, which is why we use that. But AutoCAD and SolidWorks is also really, really great if you want to keep everything on one laptop and access those designs offline. So yeah, you can for sure definitely use that AutoCAD to design your part, even print your part once you export it.
Sure. Thank you.
So given Akash, then because the team is located at different places, they're going to collaborate. So would the cloud then make a little bit more sense because then they'll be able to share it easily?
Yeah. So once we get started working, it would be helpful if you could use Fusion 360 for your design. So at the base, it's not going to be too hard to pick up if you already have AutoCAD under your belt. So it's going to be still your sketches, your shapes, your extrudes, all of that. But if you already know AutoCAD and if you're really familiar with that, it's perfectly fine if you want to use that to start and then transition to Fusion 360 as we get into that collaborative space. But yeah, once we do get started into that collaborative space and actually working, on different laptops in different places, it might help if you were using Fusion 360, just because we can collaborate that way. But it shouldn't be too different from AutoCAD.
Sure.
Yeah. All right. So if that's all the questions, I'll switch back. Again, feel free to email at robolords@gmail.com. Yeah, I'll switch.
Thank you.
Hey, great questions. So Akash, I'm just thinking, okay, so we have like about 15 minutes left, okay? So I see a lot of interest on the 3D modeling, right, using Fusion 360. Sorry, who was the person who asked that question?
Umair asked the question.
Umair,
Yeah.
okay. So Akash, is it possible for you, I know you have Fusion 360 on your laptop, is it possible for you to bring that up and just show Umair a basic modeling concept? Like we have about 10 minutes left, right?
Sounds good.
Yeah, I think we'll do that, Umair, okay?
That's wonderful.
Sure, sir.
Yeah.
Sure, sir.
Yeah, it'll be very, very interesting. And you had a couple of questions. I was just listening and you had a question about what's the difference between AutoCAD and Fusion 360. So like Akash explained, both are 3D modeling tools. Okay, the fundamental difference is AutoCAD is more popular for geometry-driven models. You know what I mean by that is civil engineers and architects who design buildings and all of that, they use AutoCAD more because it's pretty strong in geometry-driven models. Like you can build those shapes, geometrical shapes, right? And figure out the height and the weight and the tolerance and all that. Whereas Fusion 360 is more of a free-form modeling. So you can just draw a curve and you can make it as a 3D shape. right? So we use Fusion 360 a lot, primarily because ours is not a building design, right? We're doing a robotics design where we need those free-form 3D modeling tools. So that's one of the fundamental differences between AutoCAD and Fusion 360. SolidWorks is another great tool, awesome tool. We have used that for several years, but since the pandemic hit last year, we had to switch to an online cloud collaboration platform, and that's why Akash moved all our SolidWorks related work onto Fusion 360 from last year. But those are great tools. So he's bringing up his laptop, and he'll show you how to make a simple 3D model using Fusion 360. Once you know that basic concept, everything else is very similar, right? The basic concept is you draw a 2D shape. Okay, so all 3D modeling works on this fundamental concept that your drawing is a 2D drawing, right? We cannot do a 3D drawing on the shape on any of the tools. All the tools, you will do a 2D drawing first. And once you have your 2D drawing, which is called a sketch, and in some tools they call it with a different name, but usually it's called a sketch. Once you have that sketch designed using a 2D shape, then there's a concept called extrusion. It's called extrusion or extrude, right? You extrude the 3D model to make it you extrude the 2D model to make it a 3D model. Okay, so that will give the third dimension to it. And he'll show you that with few shapes. Akash, if you can do it like a simple a ball, yeah, exactly. A circle and a cube or a ball, right? And then maybe a rectangle and a cube, yeah, something like that. Great questions. And somebody else had another question about this REV Hub. You were asking about microcontrollers. Yes. So there's a bunch of hardware and software built into this. Okay. So if you think about your Arduino certainly is a microcontrollers. And sorry, I'd like to know who asked that question just so that I can connect the
Sharif asked the question.
Okay. So
Actually,
Sharif.
it's Sharif. Sorry, Sharif. Yeah.
Sharif. Okay. Yeah. Hey, Sharif. Okay. So great question again. Okay. So Arduino has a microcontroller inside it. So that microcontroller is what allows Arduino to interface with all the other analog and digital components, right? Whether it's a motor or a servo and so on and so forth. Very similar to that, this REV Hub has a microcontroller inside it, but it also has an enormous amount of software built into it. Arduino doesn't have much software, right? You have to write pretty much everything. And the microcontroller is very, very primitive. But here, what they have is a built-in Android operating system inside this. Okay, so it's called there are two versions here now from first. Okay, this is called a control hub that you see here. And this one is called a expansion hub. So up until 2018 or 2019, they had only expansion hub. So first introduced this control hub last year in 2020. Okay, and we purchased that hardware. Okay, so what this control hub has is, along with microcontroller, it also has a full Android operating system, and that's what allows this control hub to interface with the Android phones that we use for communication on the robot. Okay. So yeah, so it's a pretty powerful, hub. It's a little expensive also because of all the hardware and software that is built into it. It allows us to interface with all the motors that is allowed by FIRST. Most of the motors are from AndyMark. You could also purchase motors from Gobilda or other vendors. So it allows us to interface with all the DC motors, all the servos, then all the sensors like distance sensor and light sensor and color sensor and whatnot, right? So all of that. So it's a pretty powerful hardware device. Okay, Akash, you're good to go? Yep. Okay, so I'm going to turn off my audio here, and Akash is going to take on from his system and show you, Umair, some basic Fusion 360 modeling. Okay.
All right. So, okay, I'll go ahead and share my screen now. I have screen share access. Whoever the host is, can you please make this account screen share access?
Yeah, just a minute.
Sure, thank you.
Okay, here to go.
All right, thank you. So I'll go ahead and share my screen now. All right, so I hope everyone can see my screen with Fusion 360.
Yeah, you can see that.
All right, so this is once you launch Fusion 360, this is the base interface that you're going to come into. So you have a bunch of controls at the top, and you have this cube here. So I'll start by showing how to make a cube in Fusion 360, just, like a square and then extend it into 3D. So first I'm going to click this Create Sketch button. I click that. And then I click on any one of these planes here. So anytime you create a sketch, it asks to select a surface. So just like in real life, you can't draw a square in the middle of the air, right? You have to draw it either on a piece of paper or on a whiteboard or something. So this is asking which surface do I want to draw it on. So I'll say I want to draw it on the ground surface, which is this ground plane. I click that and I'm given into this new interface. So you can see the controls at the top have changed now that I have like rectangle, square, all that. So let's say I want to make a rectangle. So I click this rectangle button right here and I draw my rectangle using 2 points. So I click once here and then once here. And this is my rectangle. So you can see I've made a rectangle in 2 dimensions. Let's finish the sketch here. So I click finish sketch at this top right. And I have this rectangle in 2 dimensions. So you can see it's still 2D. So how do we get this to 3D? So we want to extrude it. So you click this extrude button here, select this surface, and now choose how far up you want to go. So you want to make it maybe 40 millimeters, 50 millimeters. Let's say 50 millimeters is a good estimate, a good number. So I'll set this at 50 millimeters here and click OK. So you can see how in like 2 minutes, we were able to make a rectangle together. So you could actually take this rectangular prism and put it on that 3D printer and print it out and get an actual rectangular prism there. So this is just one example of a shape you can make. How about let's try something a little bit more complex. Let's try maybe a cylinder. So we're going to start the same way. Click Create Sketch and select your ground plane as your sketch surface. And this time, instead of a rectangle, we're going to make a circle. So just click Center Diameter Circle, put it in the center. And let's say we want to give our cylinder a radius of 15 millimeters. So click this. By the way, what I pressed here is D for dimension, or I click this button here, and then click on the circle. And let's say I want to make it 15 centimeters. And click Enter. Now I have the circle here that's 15 centimeters in diameter. Once I click Finish Sketch, I can see just like before how I created a 2D circle in 2 dimensions, not the 3rd dimension yet. And to get to the 3rd dimension, all we have to do is just like before, click this Extrude button, select the surface, and select how tall we want to make the cylinder. So let's say this is a pretty tall cylinder. Let's make it 200 centimeters. This is a really tall cylinder. So yeah, let's say 200 centimeters is how long you want to make that cylinder, and click Enter. Now you can see we've made a cylinder that has a diameter of 15 centimeters and a height of 200 centimeters. So it's pretty quick, pretty easy to make that in Fusion 360 once you get the hang of it. I'll go here and I can actually show you some examples of other designs that you can make with Fusion 360. So right here, this is a little bit more complex. This isn't something you could do like that took me like 5 minutes. This is something that took a couple of some hours to make. But this is something that you can see where once you design everything in Fusion 360, it can get really easy to build. So now instead of designing parts to print, you're really designing this entire assembly to model it. So you can see, I have this chair that I can move around, all of the parts. So this is an example from one of my school clubs, but you can see how Fusion 360 can be really advantageous, really helpful for all your designing and 3D printing. So I hope that answered some questions about Fusion 360. Seeing that, is there anything that anyone has any new questions that anyone has to ask? And then if not, I think we're ready to go.
Can we download it? Is it available? Office, this one. This software, Fusion 360.
Yeah, so if you go, it's offered through Autodesk, so you can just look up Fusion 360 Autodesk download. It's for education. It's offered for free for education. There's sometimes you have to jump through some hoops to get that.
Okay, free trial.
But yeah, once you go to Autodesk, you can really click free trial download. And you have to give them some information, your login. Yeah. So, once you get in that information, you can get it. It's a free software, so you don't have to pay, but they do ask like for your name, email, and all that, if you're a student. Yeah. Okay.
Any question from anyone? किसी को कोई सवाल तो नहीं है इस बारे में जो अभी तक ने देखा इस पे?
Akash, I was asking, I was thinking, do you want as part of your, hey, for the next session or something, you want to give students some sort of homework? I don't know what is in coach, how you're structuring it, but I wanted to say if that would be something that you want to, okay, hey, everybody come up with one design by the next class or something like that.
Sure. I think Coach will talk more about that. Yeah, he'll talk more about the details. So I'll give it to him right now, actually, if there are no other questions. So that was a perfect segue, actually. So yeah, I'll transition over.
All right. Thanks, Akash. Can you hear me?
Yes.
Okay. Let me see. Yeah. Okay. Can you hear me, friends?
Yeah, you're audible. You're audible.
Okay, awesome. All right. So good question. I mean, we want to talk about those different steps. Give me 1 second. Okay. All right. So two things here. One, about the next steps. So what we need is some group of students who are interested in certain areas to know that, okay, what we should do next, right? I know that Umair asked some questions about Fusion 360, and Shahir asked some questions about microcontroller and all that, right? So certainly Fusion 360 or CAD, we can do one other session if we have enough students who are interested in that, right? But beyond that, to really get a feel of something to move forward, you need you folks to have hands-on to some hardware. It doesn't have to be a fully built out kit. It just have to be a few parts, right? So that's something we would need the students to have access to. So again, going back to Amin and Nakshib, so we need to figure out how that is made possible, how we can make that possible, right? Because theoretical sessions can only do so much. I mean, we can only have like maybe another 1 or 2 sessions, but not more than that, right? Because this is like really, this is like really a hands-on program. So students would need to have a feel of it. They need to have the touch and feel of, okay, what really it means, what this hardware part means, right? So that's something we have to figure out how we can get those resources available to the students, and how many students are in that, right? So that's one. Second is, I was also thinking, again, this just came to my mind while we were talking. So again, I'll go back and ask Ikhlas. I don't know if it's fully possible or not. We can probably have some, maybe a small kit or a small part send with Ikhlas, and you guys can meet over there. Ikhlas can show you what it is, but he'll have to bring it back. But again, I have to talk to him because he's coming alone, number one. And I don't know his, how his baggage and all is there, right? Because he wants to probably travel as a backpacker, a lightweight, right? He's a teenage traveler. So I don't want to overburden him at this time. So he's definitely coming with this, okay? So pick this from him, like his knowledge is knowledge on robotics. Talk to him, take advantage of that. But anything else, I'll figure out. I'll talk to Ikhlas and Amin and see, if he can bring something for you guys to see over there, and then he'll have to bring it back. But other than that, on a long term, we have to really figure out how to get these resources available to the students, these hardware resources, right? So I don't.
Actually,
Yeah,
Actually, I would like, we would like to have a kind of a list of these things for the basics, and then we can
Sure.
get it in phases wise. Like in first phase, what is more immediate?
Exactly. Yeah.
It's not
Exactly.
a
Absolutely. Yeah. If you look at all the hardware we accumulated, it's over a period of years, right? So you would buy some minimum basic kit at the beginning, then you would slowly expand on it. Certainly, you'll buy a 3D printer at some point in time. You'll buy other tools and so and so forth. So over a period of time, you'll start accumulating this and build all the resources over a period of time. But yes, you would start with a small kit or a small subset. Yes. And I know
Yes,
that.
so Kamal, to that question, so if you can share us, hey, maybe in phase one, what would you like to have with Naksha? We'll kind of start working on procuring those items there, and then Ikhlas can take some stuff with him that you just said. We can talk, about it later, specifically. But yeah, definitely, this is exciting. This is really exciting.
Sure. Yeah, absolutely.
And then we can manage this class in a physical space as well. So we have a tech lab, so the students may come at weekly, so we can do that.
Yes, absolutely. Yeah, it would really be helpful for all the students to be in one place because again, this kind of program requires that kind of collaboration where you are in one space, right? You are in one room, talking to each other, brainstorming with each other, discussing, debating, right? All those things. And different students will come with different skills. Like for example. Today, some students asked about Fusion 360 or 3D design. So there are students who are interested in that creative space where, I would like to imagine something, draw something, and make that feasible. Whereas some students would be interested in programming, whereas some students would be interested in microcontroller and hardware aspects of it. So, we'll see all these different skills, and they all have to blend together to form a great team. So that collaborative work requires that kind of environment where you have a conducive environment, one space where everyone can work together. Absolutely, Nakshit. Yep. Yeah.
Anyone has any question? Yeah, any comment about the session? कोई सवाल ज़हन में आ रहा है या any thought? Amar, any thought?
No, I was just asking students, you have to be very interactive. You have to ask the questions, coach and, team, Robologs team would love to hear these questions because that's how we learn together. So don't be shy. So I know this is the first session, but moving forward, we just ask the questions, any questions later on you have, just reach out. There's an email, Akash, put up there, robologs@gmail.com. So you can ask questions there also, but really appreciate, Kamal and Robologs taking time and kind of, helping to get this thing going. This definitely is very exciting.
Sure, absolutely. If there are no questions, then we can probably wrap up. And thanks again, Sia, Aditya, Akash, and Ananya, and the class for all joining together today. Thank you for taking your time out of your busy schedule to help KEI students out. So we'll plan another session sometime in near future, and we'll figure out our next steps.
I had one quick final question. Sorry,
Sure.
Between now and the next session, we'll talk background what things that we need. But is there anything that you want the students to read up on, or any resources they should look at it?
Absolutely, we can send. We'll definitely send some links to students that they can. Just give me 1 second. Yeah, they can come in. Yeah. Have a seat, okay? I'm just wrapping up, and then we'll connect. Okay, sit down. Okay, so absolutely, what we'll do, we'll send. Do you have a common, a distribution list for KEI that you would like us to send, or we just send it to you, Amin, and then you send it to the rest of the students, or how do you want to do that?
Yeah, that's much better. If you send to the one person, Amin, Sam, or me, so then we can share it with the students.
Okay. So on that aspect, I just want to share one more thing. So Akash earlier mentioned about our email address, robologs@gmail.com. But I can tell you one thing, all these students are 24/7 available on Instagram. Okay. I know for a fact Akash is available, and I can tell you that, all the other students or my team members are available 24/7 on Instagram. It's like a full-time online support. So if you have questions, they'll probably answer immediately in 5 seconds if you send it on Instagram, okay, rather than an email. Okay, so yeah, feel free to connect with Robologs at Instagram account, and post your questions as a message over there, and you will get an immediate response. That's one. And again, yeah, communication wise, I mean, email, yeah, we'll send it to you, and then you can share it, or we can form a Discord channel.
Okay.
Are you guys familiar with Discord? Do you all have Discord over there?
Yeah, many of them are using it, but
Yes, sir.
some are new. Some are
Okay.
new, so they're not. Yeah. So
Sure.
they're
Yeah.
not there.
Sure. Yeah. So we can start a Discord channel. I mean, we already have a Discord channel for Robolords, so we can start a separate for KEA interaction, where if that is helpful for collaboration, students can then again post questions, and our team members can respond to that. That's another way we can have some close collaboration, right? But yeah.
Correct, yeah. So we have Fatima, since you are familiar with Discord, can you create another channel on the access to STEM
Sure.
for Robolords or robotics here, and add
Yeah,
all
sure.
the,
That's not a big deal. That's not a big deal. I can do that.
Yeah.
so
Thank you.
get- and then help all the students here to get on Discord, so we can use that as a communication channel, Coach Pamal, if that's
Yes,
okay.
absolutely. Yeah,
And
absolutely.
then
Do that.
and then also Instagram is there, and we'll probably then also create an email where we just have like Robolards at Gmail or something like that. One group, all the students who are part of the robotics will
Right.
all of them have access to that.
Right.
Yes.
Absolutely.
Wonderful.
All right. So, all right, then thank you so much. I have to get on to another session. So thank you again so much for joining this evening. I hope you all enjoyed. And like, Mr. Amin mentioned, please ask questions, because that's the only way for us to have this encouragement to have those discussions. So I hope that there's more interaction next time. Again, thanks to Umair and Shahir for asking some questions today. And I hope you got some answers, and we'll take this forward in our next session. Okay. Thank you again.
Thank you, Robo Birds.
Thank you so much, sir.
Thank you
And thank
so
you,
much.
Robo students.
So